Hi, Doug here from the Carnegie Science Center. I'm in the exhibits department working mechatronics, and today's Behind the Exhibits, we're going to be walking you through the design process for dealing with things that aren't so normal. So we're still working on the project called Pinball Falls, and this time we're working on the electronics. So I ordered these giant cabinets here to put the electronics into. They're airtight since it's going into a chamber that's going to have big blower fans in it, and you don't want dust getting into them. So I'll be doing more videos on these enclosures in the future, but the part we're interested in today is this insert. This is what you normally would mount all of your stuff to inside. So we'll get that out of the way. So this insert here is a perf piece of plastic for mounting our stuff to. Now, the box we're working on today has to do with the spindle motors for the pitching machine. And I don't know if you remember these motors that were part of that pitching machine that had the wheels on top that would pitch the ball out. Well, these three-phase motors required a special motor controller, which is this guy here. And for this video, I happen to have a close-up camera, which I will cut to here, so you can see it. So these are the motor controllers. They have heatsink on them. There's some electronics inside that do the switching to switch between the three phases to make the motor spin in a circle. And on those is the speed controller, which is a 10K rotary resistor or a potentiometer. Allows you to vary the resistance, or in this case, the voltage to the controller to tell it what speed to rotate the motor at. Well, I need the motors to both spin at the same speed. To do that, I'm going to need a display. So this little display here has red numbers on it that read out the actual speed in RPM that motor is running, and it has a little connector on the back. These particular displays are meant to mount in a panel. So they have little nubs here on the side that push in, and it snaps into a cutout in that panel. So my first thought was, what if I took this panel here, cut out that square to mount these in? Well, the problem I ran into with that is these just are too big. Like the thickness of them when they stick down, and once you connect in the harness that plugs into the back of it, it won't fit in the bottom of the box. So I needed a way to basically surface mount these to make it easy, because also cutting a rectangular hole into this plastic material cleanly wasn't going to work very well. So what we're going to do today is I'm going to take you through the process that involves making a mount for this. So what I'm going to do is I'm going to go ahead and remote into my office computer here, and we're going to go ahead and connect to it. So here we are. So I'm using Fusion 360, and if you're a student, it's free. I highly recommend it. It's a 3D platform. It allows you to pretty much do everything from the sketch stage all the way up to even product testing and manufacturing through CNC, which we can go into that topic on another video. Now, the next step besides just this display is we need to mount the rotary potentiometer. So originally, I'm going to cut to the camera here again. It used this potentiometer here. Now we needed the RPMs to be very precise. This is what's called a single turn pot. So it only turns once from end to end. Well, this motor is meant to run between 0 and 40,000 RPM. Well, we're only using 4,000 RPM. So this potentiometer, its range was just too wide for how narrow it was. And just a movement of a single degree would cause make a jump of a couple hundred RPM. So we need something more precise than that. So what I did is I picked up one of these, if we can get it to focus here. This is a multi-turn, 20-time turn potentiometer, same 10K resistance, and there's a little screw on the end here you put a screwdriver into, and that's how you adjust the resistance, moving a little wiper back and forth inside there that changes the resistance. So this is much more precise. And I can also dial it in, and when I don't touch it, it stays put. So I need a way of mounting this to the display. So I have the display here. So one thought was, what if I just put it alongside here? So while it's in the box, you can adjust that potentiometer. So let's figure that all out today. So we'll take all this out of this camera here. All right, so in Fusion, we need to start with a new plane. So I'm just going to hit New Sketch here, and this blue line here is our Z-axis, so facing straight up away from us. So we're going to start by drawing on the flat bottom of that Z-axis. So it zooms in here. I apologize for the jitteriness. I am remoting into another computer. It's a little more powerful for this. So we need to start with figuring out a rectangle. So here is our display again, and we need to figure out its length and width. Well, you could use a measuring tape, like most people, but that isn't as precise, and it makes it a little harder for measuring things that are this small. So what we'll be using today is called a micrometer. This happens to be a digital one. This is a cheap one from Harbor Freight. They make some really expensive ones, but when we're doing exhibit work, if this happens to get dropped, we don't have to worry about losing accuracy on something like this. It's cheap. I can buy another one. So right now, you just make sure it's set to 0, and I'm using everything today will be in millimeters. No particular reason, just for the fact that my 3D printer works in metric, and it's a lot easier to not worry about the conversions later. So we'll be doing everything today in metric. So what I'm going to do is I'm going to take the micrometer and I'm going to put it across the width of this black box here. So it's 57.44 millimeters. Now that's a bit tight, so I'm just going to open it up a little bit so I have a little bit of wiggle room in there. And we're looking like at 57.64. So I'm going to set that down and I'm going to come back over here and I'm going to draw a rectangle that is 57.64. So we know I'm going to click here and here, and I'm using the measurement tool. And I'm going to look back at my micrometer, and we're at 57.44. And I'm going to hit OK for that. So that will be our width. And I'm just going to check that again. And I'm sorry, 57.6. Get it nice and loose. 57.65. So that's going to be our width. Now for our height, we need to figure that out as well. So we're going to come back to the micrometer here. And you notice there's these little nubs on the side. I'm not going to try to measure those. Those are very tight. Those are meant for fitting into sheet metal. And if I were to try to build a 3D printed thing, those would just push it out or possibly break it. So I'm only going to come up just to the bottom edge of those for this. So for measuring that, I'm going to put my micrometer on here like so. And I'm just going to measure that width. And I'm going to make it just a little bit loose so it floats just a little bit on that, like so. And I'm happy with that. That's 26.27. So 26.27, we're going to come back here, set our height to 26.27. And again, this is all in millimeters. So now we have our box here. So this is the size of the physical display. So we physically represented it in the software here. So now we need to make a part to go around that. So what I'm going to do here is I'm just going to remove myself from this video, but we're going to keep the software up just so you don't have to keep looking at my face. And from this point on, we need to put a perimeter around it. So to figure out the perimeter for this, I'm just going to measure. There's a little lip that sticks out on the side here. And I just want to see how big that lip is. So I'm going to use the bottom end of the micrometer here to figure out what that depth is. So I'm going to line it up here and touch it onto that edge and drop it down. So that gives me 2.08. So I'm going to expand on that a little bit. I'm going to go with 2.11 just to give a little volume. So we're going to draw a second rectangle around the first one. And then we're going to use our measurement tool and we're going to set our distance. So 2.11 will be our wall thickness for that. So I'm just going to set that for all of these here. And the same for the side. Now granted, there are much faster ways of doing this. I just want to show you a very simple way of going about this if you're new to Fusion. So we now have the inside cutout and we now have the outside border. So this part, I'm just hitting escape here to cancel that. This will be the outer frame that this will slide down into. So we just need a pocket that this will now fit down inside of to hold it. So we have that figured out. Now we need to mount this little tiny potentiometer on there. So we got to figure out how we're going to go about doing that. Well, first thing I need to do is I need to measure its width. So I'm going to go ahead and figure that out. So its width, 4.92, 4.93. Let's go with 4.93. So we're going to come back to our drawing. And over on the right side here, we're going to come off 4.93 millimeters. So that is the open gap that will be where the potentiometer will fit in theory. So from there, I am going to draw a second line, and it's going to come out to match the height of this line here. And what I'm going to do is I'm going to make the thickness of that the same as the other line, which we found from earlier was 2.11. So just for aesthetic reason, that's why I'm doing that. I'm now going to bring this line up. Well, how far do I go? Well, this particular guy here, we're going to measure it on its height distance here, this part. So I have 6.64 for that. So I'm going to set 6.64 for our height. Now we need to draw another line that comes out here because we've got to give this line some thickness. So we're going to go out 2.11 again, same thickness. And then from here, I'm just going to come straight down to the same distance as that, like so. And I'm going to connect over to that one. So I'm going to go from here to here. So now I have a part set up inside here, and I'm going to try to clean up some of these measurements here, because they will get away from you quickly if you're not paying attention. Okay, so what we've just created is this little output crop here. Well, there's fancy ways that you can remove intersecting lines, but to show you for this one, we're just going to delete that long line there, and we're just going to create a new one touching to that new point there. So now we have a complete solid assembly that's in this guy. So if I click this, this is the shape of our display. So what will happen is, cut to this camera, is we'll have the display, and then we'll have the potentiometer mounted basically just like this alongside of it. So while it's in the box, you can reach it from the top of the screwdriver and adjust the speed. So we also stepped it off that distance to allow for that gap that's there. So next thing we need to figure out is how far down do we need to put the bottom of this potentiometer. So this is where it's going to get a little weird. So we're going to hold it right at the very top of the display where I want it. And from there, I'm going to measure the difference between the bottom. See if I can get this all on camera here for you. So from the bottom of this here to the bottom of that. And that distance here looks to be, let's go with 7.78. That'll make sense in a second. So 7.78 is our time, or our measurement to go with. So we're going to click on solid and extrude, because we want to extrude this surface out. So I'm going to click this little arrow here, and we're going to make it into a 3D object. So we're going from that 2D plane to a 3D plane. Well, how high does that need to go? Well, we just figured that out. So 7.78. So I'm going to type in 7.78, and we have now extruded it that depth. So you can see here the little pocket where the potentiometer goes, and this is where the display is going to go. Well, now we need to figure out where the bottom of that is going to be. Well, since we figured out, if we go back to the camera here, the bottom of this distance and the bottom of the pot have now lined up, we can just make the flat bottom for that going across here. So what I'm going to do is I'm going to go to the bottom side, as you can see over here, bottom. I'm going to click on that profile and then click sketch. So we are now drawing on the bottom side of that bracket. So I'm going to zoom in a little bit here, and I'm now going to just create a rectangle that goes across that surface. And actually, we're going to do that as solid lines just to make sure I get that absolutely perfect to each corner. And we'll come down to this one, and we're going to draw a line from here down to here, like so. And then from there to there, and from there to there. So we've now created a flat base. So again, I'm going to click solid, and I'm going to hit extrude, and I'm going to click on all of these surfaces because I want this whole bottom to be extruded. And again, I'll go to the isometric view here so you can see it, and we need to extend out. Now, what you guys see the problem with this one here? Yeah, that bottom's going to be encased. So we don't want to do that. So what I'm going to do now is I'm just going to select this shape and this shape. Those are the only two parts that I want to extend out. So when I click on the solid and then extrude, it will just take those parts down, like so. Well, how far do we want to take that down? Well, this is going to be the part that sits flat on the surface of that panel that we talked about. So I'm going to put this potentiometer back up here on the surface, and this is now that bottom measurement. So how far from there down do we want to go from that bracket? Well, looking at this, I'm going to move it over to this side so it's a little easier to see, like so. I'm going to go from the bottom of that bracket down to that mark there, maybe about 4.71, because I want to have room for this to stick out and drill through a hole. And I don't want any of these things to interfere because they'll be sitting flat. So we're looking at, again, 4.71. So we're coming over to here, and we're going to go to 4.71. So we've now extruded out that piece. So this will be where the display slides down into the middle here. Our potentiometer will be on the right side here. And we have flat side. Well, how do we actually screw this down to the surface? Well, that's going to be our next process. So what I'm going to do is I'm going to click on the bottom face again. I'm going to click sketch. So we are now drawing on the bottom edge of this display. So from here, we got to put some holes and some tabs. Well, how big of a hole do we need? Well, what we're going to do is we're going to go to our bolt assortment here. And we're going to figure out what size mounting bolt we want to use to mount these. So these could pretty much be anything, honestly. But since we're using the board that's inside there, let's just happen to see if we find a screw that happens to be a close enough size to one of these holes. Tell you what, that feels pretty good. And that one there looks to be an M3 screw. Seems to line up with that grid pretty good. So nice thing about metric, let's see if it will actually hold up to me here. If you measure a metric screw, you can see very close. It comes out about 2.93 because it's an M3 screw. It should be 3 millimeter across. The thread difference makes up a little bit of that. So we need basically a 3 millimeter diameter hole. And if we want this to be able to fit through somewhat easily, I'm going to allow a little bit of slop in there. We can go with 3.18 millimeter hole. So we're going to click on a hole tool, and we're going to go with 3.18 millimeters. So that is the size of the hole that we need. So this is the part where you can kind of just drag it where visually you feel like it would look good. And then we're going to do a second hole based off of this one over here. Also 3.18 inch, or 3.18 millimeters, excuse me, in diameter. So we need to know the distance between these two holes. How far apart do we want to make them? Well, since we have this grid here that's already produced, we can just go on here and come up with a measurement that gets us close. So if I set the display down on here, I can see that we need to span what looks like from this hole to this hole here. Hopefully you guys can see that. That looks like a good distance. So what I'm going to do is I'm going to measure from the outside edge to the outside edge of two of those holes, like so. And that measurement comes out to 69.40. I bet you that's a 70-inch on square hole. So I'm going to set that to 70. And see if I'm correct. So I just set that for 70 millimeters. And I'm going to line that up there. Yeah, I'd say that's 70. Well, good rule of thumb when you're measuring things like this, a lot of times manufacturers will build things to pretty much exact numbers with some tolerances, of course. So it's a little easier when they're working on it. It also helps whenever you're reverse engineering it. So we need our holes need to be 70 millimeters apart. So I'm going to go back up to my line here, and I'm going to go from here to here, and I want my centers to be at 70. So we see we're into a slight problem here. We are now, excuse me. So we are now stuck. We can't go wide enough on that. So we need to change that. So let me remove that restraining number. And we need to figure out a wider hole pattern. So we know 70 didn't work. So we're going to go from 70 there. And let's go out 2 additional holes. Let's put us at 80. So I'm going to come back up here. And we're going to click on that. And that, and we're going to set this to 80. So that's now our new hole distance between the two. So what I want to do is drag this like so, and we want to set our distance. So I'm going to pick this line here and our circle, and it's currently at 7.8. So let's go with 6 and see what that looks like. That looks pretty good. So this is where our holes are going to end up for mounting it. Well, now we need to come over and we need to do some sort of flanges on here. So let's go about that. So what I'm going to do is, let's see the fastest way of doing this. I'm going to create a slightly bigger circle over the diameter of that. And let's make that 10 millimeters. And I'll do the same on this side. Make this one 10 millimeters. And then from there, I'm just going to draw a straight line that comes in roughly off of that over to this edge, like so. And I'm going to do the same thing on this side, come off here, and go to that edge. And see if we can grab this one to that side, and then this one to that side. So that gives us some tabs to put on the outside. So what I'm going to do, again, there's many ways to do this. Just to make sure they line up perfectly, I'm going to remove those, and I'm going to go to Create Arc. I'm going to do a 3-point arc. Give it a moment to catch up to us here. That's the joys of working with a remote desktop, as you run into some of these fun problems. So we just have to zoom in until we get proper definition on the screen there. So see how it snaps into place there? All right, so now we got our tabs designed there. We have our 3D piece that we now want to extrude out as our mounting tabs. So at this point, we want to go to solid and we want to click on extrude. And this time we want to extrude this shape followed by this shape and this shape to create all of our tabs. I'm leaving the bottom open just for breathability for that circuit board. And for how thick do we want this to be? So sometimes when you're doing designs, you can just go off visual, what you think will work. Or you can bring it in the real world using your micrometer. So let's say a thickness that I like that I know will work looks to be about 4 millimeters. So I'm going to extend that out 4 millimeters, like so. So here is our piece. We got our bottom, and there's our back. So now with the potentiometers going in here, we need a place for the wires to go. So we need a hole in the top of it, if you will. So what I'm going to do is I'm going to create a new sketch on that surface plane there. I'm going to put it all the way at the end here. So I'm just going to click on a circle, and we're going to go about here, maybe a little bit smaller, and that will be our hole. So from here, I'm going to go to solid and extrude, and we want to do a cut, and we're going to click on that piece there. And basically, we just want to extrude down through the material to do our cut. So I just dragged it down, and we now have a hole for that material to go through. So what that will do is that will give us a spot. If I do it here, our display goes here in the center, our potentiometer goes here, the wires coming out the side will go down through that hole, and then these two holes in the side are where we mount with our mounting screws, which in theory should be in line with the tabs there. And the display should slide in nicely. We've got open bottom for all of our wires and cooling to go out the bottom. So now that you've created this, the biggest step you need to do is you need to save it. So we're going to save it in design, and this will be our LCD bracket. And we're going to hit save. So from here, this is where it gets fun. Fusion allows you to directly 3D print. So we're just going to go down File, 3D Print, and you can send it to a utility. I'm not going to send it at this moment. And we just need to click the shape so it meshes it. So we're good there, and I'm going to hit OK. And it's going to want to know where to put it. So let's see here. Yeah, we'll just put it in downloads for now. And we're going to give it a name. So this is our LCD bracket again. So put that in downloads. We'll hit save. So what it's doing now is it's taking this mesh and saving it as an STL file that 3D printers can understand. So if we open up a software, something like Cura, we can use the 3D printer that I have set up here for is CME Rostock Max V3, I believe. And what we're going to do is we're just going to, well, we'll give it a moment here. Okay, so here's our file. We're going to go ahead and we're just going to drag it into the program here. So there is our bracket sitting on the 3D printer. So this is where it changes for everyone. So currently we're doing ABS, so we have a 225. Our build plate temperature is 110. ABS is a good material for doing this kind of stuff because it's very durable, as in it's flexible without breaking, as like PLA is. Let's see here on the side. We don't want cooling. We don't want cooling fans. We don't need any supports. We're going to use a brim for adhesion. So that all looks good. So what I'm going to do is I'm going to go ahead and it's kind of a shrunk down screen here. I'm going to hit slice. And it looks like it's going to take 55 minutes to print. So we're just going to go ahead and hit preview. And we're going to kind of zoom in here just to get an idea of what it's going to look like. We're going to drag ourselves down through the layers. See the structure that's built up inside there. Yeah, that all looks good. So at this point, we would just click Save to File and save it to our SD card. And then next, we'll toss it in the 3D printer and see where it goes. Print just finished. Let's see how it turned out. Open up the door. There it is. Let's grab it. I'd say that turned out pretty good. If it'll focus on it here. Get down to the surface here. Close this door. So we got some strings on there, but that is our print. And there's our little cutout for our potentiometer. So that means it goes this way. So next step is we take the display and see if it fits in there. It's a bit snug. Let me cut and we'll come right back. Right, now this is a normal 3D print, so it took some trimming with a razor blade to kind of clean up the inside edge there to make the display fit nice and tight. And you can see that our potentiometer ended up nice and flush with the top there. It's not fully seated into the socket at the moment. I gotta do a little more cleaning in there with an X-Acto knife to get it all perfect. But proof of concept, this is pretty much exactly what we wanted. So now we need to see how it lines up with the grid, if our measurements worked out. So I got our 3mm screws from earlier. So I'll put that into a hole like so. And grab another one. Look at that. So those seem to lock into the hole slots, if you will. So once those are drilled out and those are dropped in, all I have to do is drill a hole then for the wire to go through on the bottom, and we'll have a nice mount for the display to go next to the motor drivers. How cool is that? Thanks for watching.